All right, Bob. So one thing I've been curious about. We've been talking for a little while now. Thermal spray. I'm curious. What does like a failure look like in the thermal spray industry? Obviously, that's not what you're shooting for. You're shooting for perfection and making it right. But I'm
Right.
curious. What does a surface failure look like?
I could give you an answer. I've asked one of my customers if he could give me some pictures of some failed coatings, and his response was, "We never had a failed coating ever. Why would you ask a question like that?" So the reality is, yes, there are some problems out there, and we have some hiccups from time to time. And yeah, we could talk about a few of them. One of them that is a pretty common occurrence is what we call the spalled coating. And spalled means that the coating is starting to pop off of the surface that it's sprayed on. This particular image here is a good image of a spalled coating, although it's not an actual coating that was put in surface. What this is, in the thermal spray room, we have something called a plenum that draws air and draws the metal particles out of the room so the operator doesn't get killed from breathing too many metal fumes. And in this particular case, the plenum is actually has a coating on it, and it's very smooth coating. And this is zinc that was building up on the plenum, and it was just peeling off. So it's a great example of what happens if you try and spray a surface that has no preparation with thermal spray. It doesn't stick. Some people say the sugar don't stick. I think it's sugar. It's something that starts with an S. But
Yeah, I don't know if it's
yeah.
sugar, but yeah.
Oh, yeah, exactly. So this is a great example of that, and this is zinc, and it peels off. Now, okay, so this is a great example of something I observed in our spray booth, but I actually had a real life occurrence where I've seen this. This is a bridge in West Virginia, so this is like a far away shot just to give you perspective. This is a girder or an I-beam on a federal highway, and that is probably about an 8-foot web. You can judge that where the car is, going underneath there. So go to the next picture, and you can see what we're actually looking at here. And this is absolutely fascinating because I haven't been able to confirm this, but I believe this bridge was thermal sprayed and there was paint put on top. So what makes me think that is that grayish color thing is the undercoat, and the green is the paint that's peeling off. And if you look in the lower left corner, you see the rust.
Okay.
A common problem with spraying girders is that edge there is flame cut when they're manufacturing, and it has a very hard surface, and it's very difficult to get a good profile on there for the thermal spray to stick. So that's a common failure point for a thermal spray coating, is on that kind of surface there. Now, you can see up on the web, the part above that, the zinc appears to still be there, because it is. It didn't come off. The paint came off. So this is just an absolutely fascinating. I don't know how old this bridge is, and again, I wasn't able to confirm that it was thermal sprayed, but this is an example of paint spalling off a thermal sprayed surface, and the paint just didn't hold up.
Okay, so when someone like a casual person like me, doesn't not in the industry, is looking at this, should they be
Yes.
concerned about the structural integrity of this bridge?
No, they should feel safe because of it, because
Okay.
the zinc, the undercoating, is acting as the second protection layer. And out
Okay.
on that outer web, that's a hard surface. You don't see corrosion like on your car fender where it's just like going through.
Right.
Yeah, it's not. So that's a surface rust. But again, I just thought it was a really great real life example of what you would expect. And the reason why the industry is going towards coating steel girders or steel I-beams, it depends who you're talking to, and they want to spray that first with zinc and then put the protective coating on top of that, the paint coating on that.
Mm-hmm.
And they have some really good paint coatings now that are lasting like 30 years. Now, again, I didn't do the research on this. I probably can find out how, when this bridge was built and what the original specs were on it. But for the point of discussion here, it's exactly what I would have anticipated looking at a zinc coated or a thermal sprayed coating that was done with zinc on a girder. Now, this is what's called a bend sample, and this shows how a spalled coating pops off. In this case, this part was sprayed when this test strip was straight. Then we put it in a vise and we started bending it around a radius. Now, this was a pretty big radius. And this was a demonstration to the operators on if you have a bad surface prep, how the coating will not stick. So on a pretty large radius bend, the coating is like popping off, and you can see that it's just totally separating and coming off. Similar to what you saw in that bridge picture earlier where the paint was coming off. In this case, our thermal spray coating is coming off. We don't want that to happen.
Yeah.
So again, this is a simple test we can do to convince ourselves that we have the proper media, we're using the right parameters to roughen the surface, and we're using the right parameters on the thermal spray, and we'd have a good coating. In this case, this failed. This is a bad coating. This is an example of some really good coatings. You'll see that the radius is much tighter on these. And the first two pictures on the left, that coating is just starting to crack. And that's an extreme going 180 degrees like that on a sharp bend.
Yeah.
And the third one from the left, you can see there's some spalling starting to occur. So this is a successful coating that we like quite a bit. And if you dug into that, you probably see there was something with that corner right there of why it failed there. Now, there are specifications on the bend radius. We did this again as a demonstration with operators when we were doing training to show if you do everything exactly right, you can get some pretty great results on these coatings being able to bend around pretty stringent radiuses. And now let's go back to the girder example. If you had a girder that bent that far, you got far more serious problems than worrying about the coating popping off. the girder already failed.
Yes, absolutely.
So in this case, that's not going to be a big issue. Now, this is a pop coating, and it's going to be a similar cause. In this case, this was a coating that was put on an inside diameter. And what we see here is the upper part of the picture, that's the inside radius that they were thermal spraying. And the part that's closer to us is the other half of this coating. So this coating was applied to this inside diameter, and it actually popped off before they even actually went to do the machining. It popped off after they were done spraying it. And we'll go into a couple of common causes for that, but one of them also could be surface preparation. Another case of a popped off coating, a spalled coating. This is an aerospace part, and I don't know what the exact part was, but this is again is an inside diameter. You can see there in that center section, it kind of looks like is that a kind of the shape of Kentucky, maybe?
Yeah, actually, that's not bad. Yeah,
yeah. So that coating actually just popped off there on that section. Again, we think that was because of the surface preparation on that. And this is again another example of a pop coating, and there's actually two failures here. There's a crack. So you see on the very top there where that little V is, yeah, that's like the bottom part of Texas or something, huh? Something like that.
Yeah, I like that we get to, it's like the blot painting thing. Yeah, you just look at it and you try to figure out what you're looking at, the little ink blots. But this is with thermal spray failure.
Yeah. So anyway, so it actually spalled and it cracked. So this was in this particular case, I believe this was a carbide coating. And you can see that surface that it sprayed on looks pretty smooth. Mm-hmm. And that's where our inherent problem was, is there was a surface prep problem on this one also. So let's talk a little bit about surface prep. When we are prepping for spraying a shaft, and this is a good example for spraying a shaft, some of the old techniques or old school, whatever you want to call it, used to just do a thread on the shaft that you wanted to coat and do a buildup on. And they wouldn't do any other surface prep than that. It worked in that when you machined the surface, if that surface prep was good enough and you had enough adhesion, the coating would stay on. So you did a test every time. So you had confidence that the coating was going to stay on. In a case like this where they're putting on a bearing or a seal surface, that was sufficient. And it's not the great way of doing it. And there's a second, I'll call again, old school way of doing it. And that was using what we call knurling, which would be our next picture here. And again, this is a little bit better and there's more surfaces for it to hang on to. But the surfaces that are knurled still have a very smooth surface to them. That's not the best surface for thermal spray to stick to.
Mm-hmm.
What you really want to do is do a grit blast on these surfaces, which would be our next picture. And this is a little difficult to see, but on the left side is a plain carbon steel that was not prepped. On the right side is a grit blast surface. This picture doesn't do it justice, but this has what we call a raised profile of 3,000ths to 5,000ths. And it's got thousands of small little nooks and crannies for two things to occur. First of all, the total surface area is increased tremendously. So you have more area for what's called van der Waals forces to help with the adhesion. And secondly, you've got a very clean, what we call activated surface, so that it involves the van der Waals forces, which kind of gets into a topic that's much deeper than what these videos are aimed at. Now, if you use this grit blast surface on either the knurled or the threaded surfaces, that would be phenomenal. That would be your best case scenario, because you've increased the surface area and increased the places where the thermal spray can lock into it. And that's where you get your best. So in some of the cases that we just saw, the spalled coating on those three examples, where the inside diameter, that we already know was one of two causes, one of which was a poor prep surface. There's a secondary cause that we'll look at in another video with overheating coatings. But in this case, we think there was two things going on with that. We had a bad prep and we had overheating. Now, a lot of people say, well, we don't want to use grit blast because it makes a mess in our machines. This is something that's called a vacuum blast. And what we have here is the grit blast. We're grit blasting the surface of that roll, and at the same time, there's a vacuum sucking the grit back out. On this particular device, this whole thing is a grit blast device, in that the rollers there, the only thing this machine is used for is rotating it while they're blasting. There are shops that use this on older lathes where they will grit blast their cylindrical or bearing surface or seal surfaces using one of these vacuum blasts, and they keep the amount of media in the room down to a bare minimum. Other shops will use a grit blast cabinet, where they actually put it inside a cabinet that does all the grit blasting, or they have a separate grit blast room.